Hi guys, welcome to Telecom Academy. In this presentation, we have to have a look at asymmetric digital subscriber line in more detail. ADSL stands for, as I've just said, asymmetric digital subscriber line, and it runs on unshielded twisted pay. As usual, use Motion Marufu. And for any communication with me, use Motion Marufu60 at gmail.com. Or you can come via WhatsApp, that is +263 773 5878. I hope you are going to this. First things first, the aim of this course is we want to explore ADSL technology so that you guys develop a solid understanding of how ADSL operates, the network devices involved or found on an ADSL network, how they are configured, as well as some faults or some impairments that are found on an ADSL network. And this is to enable participants to deliver quality of service requirements to their valued customers. So this course is aimed at anyone who is connected on an ADSL network. Technicians that go and do some installations at subscribers' premises are going to benefit immensely from this ADSL technology presentation course. Our objectives. Let me run through them. By the end of this presentation, you guys should be able to describe the characteristics of UTP. UTP is the transmission line or the copper line that is used to carry voice and ADSL signal from the exchange to the customer's premises. So it has got characteristics in terms of losses, in terms of the frequency range. Also, we've got various XDSL technologies, VDSL, SDSL. You must be able to differentiate ADSL from those technologies. Also, there are various network devices that are found on an ADSL network. You must be able to outline their functions. For a customer to be connected onto an ADSL network, there are some requirements that must be fulfilled. You must be able to discuss them. Then in terms of access network technologies like GPON and dial-up, you must be able to compare ADSL with those technologies. Then everything has got advantages and disadvantages. You must be able to describe the advantages and disadvantages of ADSL technology. The ADSL network devices must be configured. The AAA server, the ADSL modems, the DSL. You must be able to configure ADSL modems as well as you must be able to do some configurations on the DSL. Then UTP has got some faults that are common on it. You must be able to explore those faults in general and those that affect ADSL impact. Then ADSL must be installed at the subscriber or customer's premises as well as at the MDF main distribution frame in the exchange. Must be able to do that. Then there are some faults which can be configuration faults as well as ADSL line faults. Must be able to clear them by the end of this course. For you to be able to understand ADSL technology, there are some important terms which you must understand their meanings, and I'll run through them. So let me run through the important terms. Asymmetric digital subscriber line. This means that the download and upload speed are the same. Digital examples of digital signal 0 and 1, or a discrete signal is also a digital signal, meaning that the analog signal must be converted to a digital signal. UTP stands for unshielded twisted pair. This is a copper line used to carry both voice and ADSL. The number of cycles per second is called a frequency. A modulated signal is called a broadband signal. A baseband signal, for example, the voice as I am talking is a baseband signal. It has not been modulated. Frequency division multiplexing, we are going to have a look at it when we look at the frequency spectrum of a UTP line in terms of ADSL technology. Modulation. This is the superimposition of the information signal onto a high frequency carrier signal. Modem. This is an acronym for modem and modulator, demodulator. MO modulator. DEM, demodulator, always on connection, means you simply go to the internet, is always available. You simply go to your browser, no need to establish a connection. Then downstream from the exchange to the customer's premises. Upstream, the opposite of this. A transceiver, a modem is a transceiver, meaning it has got a transmitter and a receiver. Noise, any unwanted signal that tends to perturb the proper reception of the wanted signal. A filter separates a certain type, or it attenuates or allows certain frequencies to pass through while blocking others. Appreciate key, another name for a password. Wi-Fi, wireless fidelity. A username, you know this from your computer. A password, you know this from your computer. AAA server. This is a server responsible for authorization, authentication, and accounting. Then virtual channel identifier, virtual path identifier, link. When there is connection from the transmitter to the receiver with a link has been established. Then port, you know this guys. Convergence, meaning voice and video data on one UTP line. Triple play, voice, video, and data. Then point-to-point protocol. It can be triple PoE, and that will be point-to-point protocol over Ethernet. IP address, Internet Protocol address. You will see it when you configure the ADSL modems. 192.168.1.1. This happens in a router when we change a private IP address to a public IP address, or the opposite. Then a router, this is a device that does this nothing. The presentation starts here, and this is the question: what does ADSL mean? ADSL is an acronym. A stands for asymmetric, D stands for digital, S stands for subscriber, and L stands for line. We are going to define each in more detail. Asymmetric simply means that the download and upload speeds are not the same, or you can say the downstream and upstream speeds are not the same. And on an ADSL network, the downstream speed is higher than the upstream speed. Digital simply means that our signal has to be in the form of ones and zeros, or it has to be discrete. It must not be a continuous signal. So we are saying all data is purely digital, and only at the end is where it is modulated so that it is able to be carried over the line. Subscriber line, this is a UTP line from the exchange to the subscriber's premises. It is a copper line. Let's compare ADSL with other access network technologies, and these are compared to various. In this case, dial-up is being compared to a tortoise, and we know that a tortoise is very, very slow. Integrated services digital network is being compared with a bicycle, and we know that this is faster than this, but this is slower than a motorbike. So ADSL is faster than ISDN. ADSL is also faster than dial-up, but we've got some variants or some other flavors of XDSL, like very high bitrate digital subscriber line 2. This is a standard of ADSL. ADSL 2 plus, this is a maximum downstream speed of 8 megabits per second. This is a maximum downstream speed of 24 megabits per second. Hence, it is being compared, or its speed rather is being compared to a motor vehicle. We are assuming that the speed of this motorbike is less than the speed of a motor vehicle. Then this stands for FTTX. This is a GPON technology. And please take note that these the three are being represented by a hybrid, which means there's a combination of optical fiber and UTP. Then fiber to the home is a pure fiber. There is no copper or UTP, hence you can see this speed is the fastest. So please take note that ADSL speed is better than these two, but when we include a portion of fiber into our ADSL network, it will surpass these speeds. Every transmission media has got a range. We are now going to look at a range, and we are saying ordinarily ADSL can go for a distance of 5.5 kilometers from the exchange or from the DSL, and the assumption is we are using the mostly commonly used American wire gauge for the transmission of the ADSL signal or for voice signal. Please also take note that this rate decreases as the distance increases towards the customer's premises, and the opposite is true. That is to say, the further the customer is away from the exchange, the less this speed. To extend the range, we use a hybrid combination of optic fiber and copper. So we are saying it is possible to extend the local loop by incorporating optical fiber. And since optic fiber has less losses, it can cause the ADSL signal to exceed this range of 5.5 kilometers. What are the factors that affect ADSL speed? Because when we did a comparison in one of the previous slides, we saw that its speed is only better than that of ISDN as well as dial-up. And the factors that affect ADSL are the distance from the local exchange or from the DSL, which means the further the customer is away from the exchange, the less the speed. And also the type and thickness of the UTP line, because we know that resistance R is equals to rho L over A, meaning that resistance increases as the cross-sectional area of the UTP decreases. So we are saying the thinner the wire, the less the speed of ADSL. And also the number and the type of joins on the UTP line. We know that any join is a point of power loss. So we are saying the more the joints and also the type of join, the more or the less the speed, meaning the more the losses. And also interference in any line. Interference is a form of line. We'll cover this when we do Shannon-Hartley law. So we are saying interference from other line like ISDN and also other non-voice signals results less ADSL speed. And also some other signals that are not from the same line. Any other signal from some radio transmitter, for example, if it gets into the UTP line, it is a form of noise, hence it is going to result in reduction in the capacity of a UTP line, meaning less ADSL speeds. So guys, these are the factors that affect ADSL asymmetric digital subscriber line speed. Take note of them. What are the requirements that are needed for a customer to be connected to an ADSL network? We are saying for a customer to be connected to an ADSL network, the following are required. There must be a phone line from the exchange to the customer's premises. No phone line or no UTP line from the exchange, no connection to an ADSL network. Also, a splitter is needed to separate voice signal from an internet signal. This is a requirement if the customer wants to have voice and internet access at the same time. If he doesn't want to have the two at the same time, then this is not a requirement. Also, please take note that an ADSL modem must be installed at the subscriber's premises. This ADSL modem has got a lot of functions. Then the last requirement is that you must be paid up for you to enjoy ADSL service, or for you to enjoy internet when you are connected to an ADSL network, meaning there must be a subscription with the ADSL service provider. The ADSL modem does the function of a router, which does the routing function. This is where you connect your laptop. It can be wirelessly or using a cable for you to enjoy internet access. Modulation. We've got two types of modulation that are used in ADSL technology: carrierless amplitude phase modulation, as well as discrete multi-tone modulation. We say the modulation is the superimposition of an audio signal or the wanted signal onto a high frequency carrier signal, so that our intelligence or the wanted signal is able to propagate for a greater distance, because the carrier signal is able to do that. So we are adding some characteristics of the carrier signal, which in most cases is an analog signal. What is carrierless amplitude phase modulation? This is a type of modulation that divides our UTP line into two distinct bands. If you remember your FDM, frequency division multiplexing, that's the upstream channel, which is the channel from the customer's premises to the exchange, is going to operate a frequency range from 25 kilohertz to 138 kilohertz. Then the other band is the downstream data channel, which means from the premises to the user, and this occupies a frequency range from 200 kilohertz to 1.1 megahertz. 1.1 megahertz or 1 megahertz to the nearest is the bandwidth for UTP line. Hence, you can see the reason why we have got less speed on ADSL when compared to fiber. So we are saying these channels are widely separated, normally by the guard band, so that we minimize the possibility of interference between the upstream channel and the downstream channel. And we are saying this separation is called the guard band. Another type of modulation that is used on ADSL technology is called discrete multi-tone. A brief history of this: it was developed by John Siofi of Stanford University, and this guy managed to use it to transmit 8 megabits of information per second across a 1.6 kilometer long line. So we are saying it has got better speed of data transfer, efficient use of the bandwidth, as well as better consumption of power when compared to carrierless amplitude phase modulation. More detail of discrete multi-tone DMT: we are saying it separates our ADSL line into 256 channels, each of 4.3125 kilohertz. And of these 256 channels, obvious, because we want more downstream speed, it means that 224 of the 256 channels are reserved for the downstream channel and the remainder for the upstream channel. This explains why download speed is higher than upstream speed. And we are saying of these carriers, discrete multi-tone constantly shifts these signals between the different channels to make sure that only best carriers or good carriers are used for transmission and reception. No data is sent to the frequency bands that are bad. More on discrete multi-tone modulation. As we said, the line is divided into 256 sub-channels, each of bandwidth 4.3125 kilohertz, and we are saying if we allocate 25 of these to the upstream speed, it means that for us to get the upstream speed, we are going to say 25 carriers multiplied by 8 bits plus the bandwidth roughly to the next 4 kilohertz. So the upstream speed in this case will be 640 kilobits per second. If we allocate 224 carriers of this to the downstream speed, to get total downstream speed or download speed is this channels 224 multiplied by 8 bits multiplied by the bandwidth of each of the nearest, which is equal to 4 kilohertz. As you can see, downstream speed, because it has got more channel carriers, it means that it has got a higher download speed when compared to the upstream direction. As you can see, this is the frequency spectrum of ADSL discrete mode tone. This is used for voice, this is used for upstream, and this is used for the downstream. You can see that it's from 0 to 255, making 256 sub channels. Please take note. In analysis of the frequency spectrum, so we saw that the bandwidth of UTP is 1.1 megahertz, and according to our fig 1.1, we saw that the upstream is from, all our ADSL signal occupies a bandwidth of 26 kilohertz to this 1.1 megahertz, and this covers both the upstream and the downstream, and all the frequencies below this cover the guide band as well as the voice. And we know that voice is from 0 to 4, so from 4 to something less than 26 kilohertz, it's our guide band, so that there's no interference between voice and downstream. And so we are saying the frequency spectrum from 26 kilohertz to 138 kilohertz is our upstream transmission channel, and that from 138 kilohertz to 1.1 megahertz is our downstream channel, as shown in the previous slide. So we are saying the frequency spectrum above 26 kilohertz is going to be divided into 249 independent sub-channels, each containing this, as we saw, and we are saying, I think this has been covered in the previous slide. We saw that 25 channels for the upstream and 224 for the downstream. We said broadband is a modulated signal. It can be analog modulation or digital modulation, and in this case on ADSL it's digital modulation. So we are saying ADSL is motivated by the pre-existence of a line from the customer's premises to the exchange, and all along this line has been used to carry voice alone. So when ADSL was discovered, it made use of the same line that was used to carry voice, hence it is motivated by the pre-existence of a local loop. Local loop simply means the UTP line. So we are saying an unloaded twisted pair of copper wire from the exchange to a customer's premises can carry a digital signal that is higher than 1 megabits per second up to 5 kilometers when compared to a 4 kilohertz analog voice signal, and this can carry a line at 56 kilobits per second. So we are saying, please take note that ports simply means voice. We are saying plain old telephone system, which is a phone that was used to carry voice alone. So we are saying that what we mean by an unloaded cable. Loading of cable was done in a way by adding some conductors at predefined distances along the line from the exchange to the customer's premises. So for ADSL to operate these inductors that would have been put along a line, the process called loading must be removed, or else ADSL will not operate. So we are saying the distance can be increased for analog telephone line for voice alone if we load cables. This helps to compensate for loss and dispersion. However, they cannot support digital subscriber line as the loaded coils attenuate high frequency signal. You can find out from inductive reactance SL is equals to 2 pi FL, meaning the higher the 2 pi FL, the higher the inductance, the more the inductive reactance. Please take note. We said broadband is a modulated signal. It can be analog modulation or digital modulation, and in this case on ADSL it's digital modulation. So we are saying ADSL is motivated by the pre-existence of a line from the customer's premises to the exchange, and all along this line has been used to carry voice alone. So when ADSL was discovered, it made use of the same line that was used to carry voice, hence it is motivated by the pre-existence of a local loop. Local loop simply means the UTP line. So we are saying an unloaded twisted pair of copper wire from the exchange to a customer's premises can carry a digital signal that is higher than 1 megabits per second up to 5 kilometers when compared to a 4 kilohertz analog voice signal, and this can carry a line at 56 kilobits per second. So we are saying, please take note that ports simply means voice. We are saying plain old telephone system, which is a phone that was used to carry voice alone. So we are saying that what we mean by an unloaded cable. Loading of cable was done in a way by adding some conductors at predefined distances along the line from the exchange to the customer's premises. So for ADSL to operate these inductors that would have been put along a line, the process called loading must be removed, or else ADSL will not operate. So we are saying the distance can be increased for analog telephone line for voice alone if we load cables. This helps to compensate for loss and dispersion. However, they cannot support digital subscriber line as the loaded coils attenuate high frequency signal. You can find out from inductive reactance SL is equals to 2 pi FL, meaning the higher the 2 pi FL, the higher the inductance, the more the inductive reactance. Please take note. Another word that we discussed in our earlier slides is a transceiver. In this case, our modem acts as a transceiver. Please take note that on any UTP line, we must have two modems. Modems operate in pairs, hence the name modem, meaning modulator, demodulator. If you modulate at one end, you must demodulate at the other end. So we are saying we've got two transceivers, one in the DSLAM and another at the subscriber's premises. These you will see that they are referred to as a TUC and a TUR in one of the slides ahead. And the responsibility of these two transceivers, or of the two ADSL modems, is they do the multiplexing and demultiplexing of voice and data. Why? Because we want to adapt our digital signal to the characteristics of our UTP line so that there is efficient transmission of our ADSL signal. And please take note that we discussed that downstream signal has a higher data rate or higher speed when compared to upstream. Guys, this slide on Fig 1.2 is very, very important, and it is referred to as ADSL reference model. And we are saying we've got a local loop, which is our UTP line that links the customer's premises, which is this end, and the exchange side, which is also referred to as the central office. And we've got two networks. We've got the PSTN network, which is the switch that deals with our analog voice, and we also have the data network, which is our internet side. So we are saying on an ADSL network, we must have two transceivers at the two ends. One at the subscriber's premises end, it is known as the ADSL transceiver unit remote meaning far away from the exchange, and the transceiver in the DSLAM is known as the ADSL transceiver unit central. So we are saying the exchange is central to all other lines that service our customers. And please take note that we have got two filters. These are responsible for separating voice from data or from our ADSL signal. So a low pass filter blocks ADSL signals because they occupy a higher frequency spectrum. We saw that from 26 kilohertz. So it passes, or it allows voice to pass through so that it is processed by our telephone receiver. Then this is our modem. Our modem contains a high pass filter which is going to block low frequencies so that they won't be able to pass. And this is where our computers or some smartphones connect. And in the exchange, we have got the same device, which is our ATUC, and we are saying this contains a high pass filter. The same applies to the ATUR. There's a high pass filter. This is going to block voice frequencies so that voice frequencies are going to go via this route, and they are going to be attended to or to be processed by our voice switch, or ADSL signals are going to be forwarded to our data network. So guys, you must be able to label all these components. This is an ADSL modem or a TUR. This is a computer or a user terminal, also known as the customer's premises equipment, for example, a PC. This slide is simply repeating the previous ADSL reference model, and to summarize, we are saying we have got two transceivers, ATUC and ATUR. And we are saying ATU stands for ADSL transceiver unit, C standing for central, and this is found in the DSLAM at the exchange. This R stands for remote, and this transceiver is found at the subscriber or customer's premises. These two are responsible for modulation and demodulation depending on whether it is upstream or downstream. So we have got two ADSL modems and we've got two splitters, one in the DSLAM as well as one at the subscriber's premises. These two splitters are responsible for separating voice and data. Let's have a look at the generic ADSL network architecture. And please take note that we are saying this is generic, and there might be some variations because of technology changes. Like in this case, we can have one device doing the voice switching as well as that same device providing internet access. So we can have these two being combined, and then from there we proceed to the internet service provider ISP, or to the internet or to the data network. So what are we saying? This is our local loop, which is our UTP line linking the customer's premises to the central office or to the exchange. And we've got two splitters. Guys, take note, on N1 ADSL line or on N1 local loop. This is found at the subscriber's premises to separate voice. So downstream data is going to be split into voice and ADSL signal. ADSL signal is going to be routed to the ADSL modem or to the ATUR, and this is where our computer is connected, in this case using an patch cable. Then voice signals from the splitter are routed to the analog telephone receiver, and this is an RJ11 cable. This is also an RJ11 cable. So we are saying the splitter separates voice and data, but guys, please take note that strictly speaking, the low pass filter is the filter that is only found inside. Sorry, yes, it's correct. It's the filter that is only found in the splitter. The high pass filter is not found in the splitter, but in the ADSL modem. And I said you can connect this telephone receiver to either of these two ports. You will hear a dial tone, which is voice. Then in the exchange or at the central office, we've got a splitter that is going to separate voice and data. The low pass filter is going to allow voice signal to be processed by the telephone switch, and the data is going to be routed to the internet or to the data network. So this is basically the way how this generic ADSL network architecture is connected or is arranged. Those with no background at what a filter is, we are going to cover that. We've got many types of filter. We've got low pass filter, which allows low frequency signal to pass through, for example, voice. We also have high pass filter, which blocks low frequencies, thus allowing high frequency signals such as ADSL signals to pass through. So LPF stands for low pass filter. HPF stands for high pass filter. Then in RF communication, we've got what we call band pass filter. This allows a certain band of frequencies to pass while blocking all other frequencies. The band stops is opposite of this. It blocks a certain band while allowing frequencies lower than the band and higher than that band to pass through. So we are saying low pass filter allows low frequency signals to pass through while blocking high frequency signals, and our good example is voice, which occupies a frequency of 0 to 4 kilohertz. So we are saying, in other words, ADSL signals are high frequency signals, and these are blocked by or attenuated by the low pass filter. And a high pass filter allows high frequency signals to pass through while blocking low frequency signals, meaning it blocks voice frequency. So we are saying ADSL signals are high frequency signals, and we saw that they occupy a frequency. They occupy frequencies from 138 kilohertz to 1104 kilohertz. And these are allowed to pass through. Band pass filter and band pass filter and band stop filters are not found in this splitter, and we are not going to cover them in this course. One of our objectives was we must be able to explore ADSL advantages and disadvantages, and we are now doing that. Advantages of ADSL. We said ADSL rode on the technology of PSTN, or plain old telephone system, which was running on UTP line. So we are saying it does not require the use of a second phone line, since the same line that is being used to carry voice can be used to carry ADSL signal or data. So this is the first advantage of ADSL technology. No need to install a second line. Also, it can be installed on demand, unlike optic fiber, which needs substantial underground work and significant installation at the customer's premises. Because we said the ADSL technology makes use of the same line, it can be installed on demand. If a customer has an already telephone service, you simply proceed to his or her premises and do the installation, that it can be installed on demand. Please take note that the broadband access speeds of ADSL, they are significantly higher when compared to dial-up. Dial-up has got speeds of 56 kilobits per second. And also on ADSL, there is no need for dialing up to establish a connection. You simply go to your browser and you are on the net. Whereas for dial-up, the modem has to do the dialing first for a connection to be established before you go to your browser. And the last objective, but not the least one, we are saying there is less risk in ADSL technology since our line is not shared like in GPON. Each customer has got a dedicated line, so there is no risk or there is no need for a lot of encryption as what happens in GPON. There is also no sharing of speeds as what happens in GPON from the DSL to the subscriber's premises. Let's look at the disadvantages of ADSL. We are saying as the signal is propagated from the exchange to the subscriber's premises, it is affected by the resistance of our UTP line. Hence, there is much attenuation in the UTP line such that the range is limited to 5.5 kilometers as we saw. So this reduces the reach of ADSL, whereas GPON can go further than that. Also, ADSL runs on UTP, and UTP is prone to electrical noise. It is prone to, apart from attenuation, we have got a lot of interference from other ADSL or data signals. Also, it is prone to noise due to moisture, corrosion, as well as crosstalk. Some XDSL flavors. This X stands for some types of DSL. DSL stands for Digital Subscriber Line. So we are saying ADSL, our X will be A. For VDSL, our X will be V. For our HDSL, which is this, our X will be H. Hence, we refer to that as flavors of XDSL. So we are saying we've got several types of these. And ADSL is the most widely deployed type of digital subscriber line. That is, it provides connectivity primarily to residential subscribers, although we have got 20% being some business customers. Then another flavor of XDSL is called very high bitrate digital subscriber line, and its speed is far much better than that of ADSL. We saw from that slide that VDSL was being represented by a motor vehicle. So we are saying then it was an emerging technology and it supports higher bit rates when compared to other DSL flavors. And it is able to meet the needs of residential as well as business customers. Then another flavor of XDSL that we are going to discuss is called HDSL, H standing for high bit rate. So this is a relatively mature technology in the XDSL family and is now widely used. It makes use of one or two twisted pairs for transmitting. It can be one pair or it can be two pairs, and it can support full duplex. T1 means speeds of 1.544 megabits per second, and its variant is called, this is for America and Canada, this is for Europe. They refer to this technology T1 as E1, and it has got superior speeds 2.048 megabits per second. And as I said, HDSL stands for High Bitrate Digital Subscriber Line. All these three flavors, they make use of a modem. We are now going to have a look at ADSL standards, and the first standard of ADSL is known by these three names: G.DMT or full rate ADSL or G.992.1. And we are saying this is the first version of asymmetric digital subscriber line, and there is simultaneous transmission of voice and data, and the upstream speed 640 kilobits per second, and its range is from 25.8 kilohertz to 135 kilohertz for the upstream, whereas for the downstream the speed is 8 megabits per second, and the frequency range from 138 to 1.104 megahertz, and it uses a discrete multi-tone modulation standard. Then we've got another ADSL standards known as G-Lite or G.992.2. It is also known as splitterless ADSL. We know that one requirement for a customer to be connected onto an ADSL network is a splitter. This standard wanted to do away with this requirement, and its upstream speed is 5.12 kilobits per second, which means that it is slightly lower than that of ADSL or of full rate ADSL, and its downstream speed is also lower, about 1.5 megabits per second. This, please take note that it was a commercial failure. It was based on reducing complexity, especially at installation, so that a customer can do self-installation. So this is another standard of ADSL. Please take note that it failed. ADSL standard is also known as ADSL 2 or G.992.3 or G.992.4. So we are saying its maximum download speed is 12 megabits per second, while its maximum upload speed is 1 megabits per second. This must be the upstream speed, and this must be the download speed, not the difference with ADSL, the first standard of ADSL known as ADSL or the G.Lite, not the differences between the upstream as well as downstream speeds. This standard makes use of pilot tone reordering and pilot tone reposition so that it becomes robust, and it enhances diagnostic. This standard extends the range of ADSL or the basic standard of ADSL by 189 meters. Then the last standard of ADSL that we are going to have a look at is called ADSL 2+. And please take note that the maximum speed doubles from 12 megabits per second to 24 megabits per second, but the downstream speed remains the same at 1 megabits per second. ADSL network devices. And we are going to start by exploring ADSL modem. ADSL modem is also known as ADSL transceiver unit remote with reference to the central location, which is the exchange. So we are saying this is found at the customer's premises or at the end of the UTP line. And what is its function? It demodulates downstream or the incoming signals while modulating upstream or the outgoing signals. So it does two functions. It does modulation and demodulation. Hence the name ADSL modem. Its other name is also known as Customer's Premises Equipment, CPE, or XTU. In this case, our X is A, hence the name ATUR. And R may designate any generic ADSL customer modem, such as VDSL, HDSL. That's the basic function of the ADSL modem. It also allows the customer to connect to it using some cables and also wirelessly. Hence, it allocates some. It also does the function of a DHCP, Dynamic Host Configuration Protocol. It allocates IP addresses, or it releases IP address devices that are connected to it. And normally, the lease period is 1 day, that is 24 hours. Typically, a TUR is a standalone unit, and it provides, as I said, USB connection or Ethernet connection to a computer or to a networking equipment. It can also act as a wireless access point, thus enabling IEEE 842.11 connectivity. And for business services, a CPE may perform some routing as well as some switching functions. That issue of allocating IP addresses automatically using DHCP is a routing function. So that is it insofar as ADSL modem customer's premises is concerned. Another ADSL network device is known as a splitter. It does the splitting function. It separates voice and data or voice and ADSL signal. So this happens if DSL is operating non-invasively or together with plain old telephone system, which is our normal telephone voice. A splitter is required at subscriber's premises and also at the exchange to allow simultaneous use of ADSL and telephone on the same physical line. You can totally remove the splitter in that case when you don't want to make use of voice. But if you want to make use of voice, make sure the splitter is connected and it has got 2 outgoing ports and 1 incoming port. And 1 outgoing port is connected to the ADSL modem, while the other port is connected to the analog telephone line. We looked at a low-pass filter and a high-pass filter in detail in one of the previous slides. So we are saying it filters out ADSL and presents a clean telephone signal to the telephone receiver. This is the function of the low-pass filter and also a high-pass filter. It attenuates or blocks voice while presenting a clean ADSL signal to the ADSL modem. So please take note of this important point, which says the characteristics of the high-pass filter are crucial to ADSL operation. Hence, the high-pass filter is typically put into the transceiver or into the ADSL modem instead of into the splitter. You can prove this. That the high-pass filter is not in the splitter but in the ADSL modem. Then in the upstream direction, what are we do? We want to make sure that our signals, the voice as well as the ADSL signal, are confined to their correct frequency spectrum. Hence, we are saying it does that function in the upstream direction by combining the 2 signals, and also it presents or it forwards the 2 signals to the local loop or to our analog telephone lining after restricting them to the required bandwidth. Then we are going to have a look in the next slide to see the way how a splitter operates or how it separates voice signal, which is plain old telephone signal, as well as the ADSL signal. And please take note of the following assumption. We are assuming that the high-pass filter is inside the splitter and not in the ADSL modem. And the installation of the splitter at the customer end, it requires a skilled technician, because you can vice versa the ports, output ports, and if you do that, the phone will work, but the ADSL modem won't synchronize with the one at the exchange. In illustration of the splitter functionality, we have got our UTP line carrying ports plain old telephone system, which is our voice signal as well as the ADSL signal, all are carried by the same UTP line. Then we've got our splitter. This is our splitter, and inside the splitter, that's where we find the low-pass filter, and also we are assuming that this is where we find the high-pass filter. So these two signals, when they get to this point, the high-pass filter is going to go, or the ADSL signal is going to go in this direction, rather, while the voice signal is going to go in this direction. So we are saying the low-pass filter allows low-frequency signals 0 to 4 kilohertz to pass through, and they are processed by this analog telephone receiver. Hence, you can see that this part is the same as this part. So this is going to process the voice or the telephone signal. And please take note that in the upstream direction, this is occupying a high frequency band, but it is going to be restricted to this band by this filter. For the ADSL modem, the high-pass filter is going to block voice, so we are assuming in this direction, voice which was occupying this part has been stopped by this high-pass filter, and only the ADSL signal is going to proceed to the ADSL modem, and this is in the incoming direction. In the outgoing direction, which is in the upstream direction, as you can see, this is occupying a wider frequency band when compared to this. So after the signal at this part of the filter, this one, so we would have confined this signal to this frequency spectrum in the upstream direction. So this is a good explanation on the splitter functionality both in the upstream direction as well as in the downstream direction. Please take note of the outgoing and incoming frequency range of the voice as well as the ADSL signal. This is an explanation of the previous slide. So we talked about low-pass filter and high-pass filter, and we are saying the low-pass filter allows low frequencies of voice that's 0 up to 4 kilohertz to pass through, and it attenuates or it reduces the amplitude of all signals above 4 kilohertz in the received direction. Please take note, this is important. A high-pass filter attenuates or it clips all frequencies below 4 kilohertz or lower frequencies, while allowing ADSL frequencies, which are high frequencies from approximately 26 kilohertz up to 1.1 megahertz. So we are saying there's nothing from 0 up to a few kilohertz that is going to be allowed to pass through this high-pass filter, and we call this blocking or attenuation. And please take note that this is in the receive direction. So please take note of this important point. In the transmit direction, we do not talk of attenuation since the telephone receiver does not generate high frequencies, while ADSL modem does also not generate low frequencies. So the low-pass filter and the high-pass filter enables us to separate voice and ADSL or data signals. Why? Because they occupy different frequencies or different frequency spectrums. Questions? You can try these questions. You can always refer to the video presentation. Describe how you can prove that high-pass filter is not found in the splitter. This is very easy. If you take your telephone receiver and connect it to the ADSL port on the splitter, you will hear a voice. So that shows you that the high-pass filter is not in the splitter part, it's found inside the ADSL modem. Describe how you would connect customer's telephone receiver and ADSL modem to the telephone line. Describe how you would connect customer's telephone receiver and ADSL modem to the telephone line. Please take note that you must have an RJ11. Your line must terminate on an RJ11. Then you must have an RJ11 socket, and you must have an RJ11 cable from the to the ADSL splitter. Then the splitter has got one incoming port, so that's where you connect the cable from the RJ11 socket. Then the two outgoing ports, the ADSL modem is connected to the port connected or labeled internet or ADSL. Then the phone is connected to the port labeled phone or such. Then question number 3, a customer's modem connected to the splitter by a technician was not synchronizing with the one in the DSL. What do you think was the problem, considering that the line was of good quality? The technician might have made an error if vice versa. He connected the telephone line to the ADSL port and the ADSL modem was connected to the phone port. Hence, it was not syncing with the one in the DSL, despite the fact that the line was of good quality. Normally, if the line is not good, the two modems won't sync